HVAC 21, is there a general rule when to account for motor efficiency and when not to account for efficiency? Yeah, is there a general rule? It's kind of a general question, so it's hard to know what situation you're applying that to, but I guess what comes to mind for me there is two things. One is to always remember that motors are rated in their output, which is bhp. So let's imagine we have a motor, and that motor receives some electrical input. Usually we think about that in kW. And then it produces some output, and usually we think about that in brake horsepower. Not that we have to, right? If you're in Europe, they think about the output of their motors in kW. So that's actually kind of nice, which is always the case with the SI system, right? The units are nice. And in the US customary system, they're not so nice. But so like if you want to find the efficiency of a motor and you're in Europe, then efficiency is always output over input. It's what you get out compared to what you have to put in order to get it. And since both of those will already be quantified in kW, you can just go ahead and divide and you get the efficiency, which is unitless, as it should be. But in US customary units, we tend to think about the output as being in bhp, but we can convert the units, right? These are both units of power, so we can go from watts to horsepower, and that's no problem. You just have to know how to do that or use the reference handbook to do that. So in terms of rules of thumb, if we say we have a 5 horsepower motor, we're talking about the output. Output is 5 horsepower. So there's always going to be an input that's larger than that. Input is larger than the output because of the losses. And the delta, the losses, is the input minus the output. So that's the first kind of rule of thumb to think about. And then from an HVAC perspective, if you're thinking about cooling an environment that has equipment in it, such as motors, then you want to be mindful of whether that motor is in the conditioned space and also whether the driven equipment is in the conditioned space. So if only the motor is in the conditioned space, but the driven equipment is not. So let's imagine this motor is driving, I don't know, pumps or something, but they're outside the space. Then all you have is a room with a motor in it. And the only cooling that you need to do is the cooling that's necessary to address the losses. So the difference between the input and the output, that represents heat that's going to go into that room that then needs to be removed. But if you have a situation where the motor and the driven equipment are both in the conditioned space, then actually we don't know how much of that output actually goes into producing heat. So the typical assumption that's made is that all of it produces heat, which is very conservative, but it's what's normally done. So in such a case where your room contains the motor and the driven equipment, then you're going to have to provide enough cooling to make up for the entire input energy of that motor. So whatever that kW is, you convert that to BTU per hour, and that's how much cooling you need. So I guess that's not really a rule of thumb. That's the method for solving such a problem if that's what you're driving at. So the general idea is to be mindful of whether the motor is in the conditioned space and also if the driven equipment is also in the conditioned space. And that should help you figure out how much cooling you need to provide.